Okay, so for today's lesson, you're going to watch this video and record your notes, and then you'll bring those back to me to class and show me that you did it, and that will count as your homework. Okay, so what you're going to learn about in this lesson is writing formulas and naming formulas. And there's three basic kinds. There's the ionic compounds, molecular compounds, and acids. So the first thing you're going to have to be able to do is identify which type of compound you have. And that's what this tells you right here. Ionic compounds are made up of metals and nonmetals. The metal's going to be first. So the example, Al is aluminum, which is a metal, and this is how I know this is an ionic compound. Metal will be first. Okay? The other type of compound are molecular compounds, and they are made up of only nonmetals. So the example, sulfur dioxide, sulfur is a nonmetal, oxygen is a nonmetal, so this is a molecular compound. And then acids are identified by the fact that they have a hydrogen first. So if you look at the example, H2SO, that should be a 4. Okay, that is sulfuric acid, and it's named accordingly because it has a hydrogen first, and then nonmetals to follow. Okay, so we're going to concentrate now on just ionic compounds. Okay, ionic compounds are made up of ions, a positive ion and a negative ion, and ions are formed when they gain or lose electrons. Okay, and we write their symbols with a superscript of the charge in this corner here. Okay, so sodium as an ion loses 1 electron, so that makes it have an overall charge of a positive 1. Magnesium loses 2 electrons, so you're left with a positive 2 charge. And aluminum loses 3 plus charge. These are all called cations because they are positively charged. I remember that these are cations because it has a T right here, which is a lot like a plus sign. Okay. The other kind we're going to talk about are anions, which does not have a T, so those are negative. Okay. When you name a cation, the name doesn't change much at all. It's the same name as the element. Okay, so if I was naming this, I'd still call it sodium, but I would put ion at the end of it. So this is sodium ion. Okay, and this one is the magnesium ion, and this is the aluminum ion. Okay, but when we do negative ions, which would be your non-metals, okay, anions are what negative ions are called, and they all have an N in there. Anion, non-metal, negative. Okay, so like chlorine. Chlorine is a non-metal. It gains an electron, and that's where the negative 1 charge comes from. And oxygen gains 2, and so on. Okay, these, when you go to name them, is not exactly the same name as what's on the table. You take the ending and you change it to "ide." Okay, so this is not chlorine anymore, it's called chloride. And there's no need to write the word ion after it, because you would automatically know if we're calling it chloride, it would be the ion. Okay, then O2 would not be oxygen anymore, it would be oxide. And bromide and sulfide. Okay, and all the others, there's fluorine. Fluorine would be fluoride. Iodine would be iodide. Nitrogen would be nitride. Phosphorus would be phosphide. Carbon would be carbide. And so on. Okay, so those ions, anions and cations, come together to form ionic compounds. And they do so that they are electrically neutral. That means you have an equal number of positive and negative charges. So when you write their formulas, that is your goal, is to make their charges equal 0. We call this a formula unit. That's the smallest particle of an ionic compound. Okay? Okay, so NaCl is a 1-to-1 ratio because sodium is a positively charged ion of a +1, chlorine is a negatively charged ion, and so a +1 plus a -1 gives me 0. So we only need one of each ion. Okay? And to name them, you just put their two names together. This is sodium, and now this is an ion, so it's chloride. Sodium chloride. Calcium oxide. Magnesium bromide. So they all end in "ide" because they're binary, which means they're made up of only two different elements. Okay, so what we're going to do next is go to your blank periodic table and fill in the charges for all the ions. Okay, which we did earlier in the year. You took a quiz. Okay, so in this first group, what you learned was that these all have a +1 charge. If they're metals, because metals are positive ions. Hydrogen is actually a non-metal. So remember, it can do both +1 and -1. And then +1 all the way down. Okay? Okay, the next group is group 2 or 2A, and you learned that these are all positively 2 charged, +2. So +2 all the way down. Okay, go ahead and fill that in, +2 all the way down. Okay, then we'll come back to the transition metals and we'll go to group 3A. And if they're metals, they're positively charged and they would be +3 according to our pattern. So for just the metals, you want to fill in that charge, which would be aluminum and gallium. Okay, boron is a metalloid and it doesn't really like to form ions, and neither do these two, so we leave them alone. Okay, then the next group is +or -4. Again, plus for the metals, minus for the non-metals. So carbon is a non-metal, so its charge is typically a -4. Silicon is a metalloid, and it typically doesn't like to form ions, so we skip that one. Same thing for germanium, and we'll go on to tin, which can be a +2 or a +4. It can form more than one ion. Same thing for lead. +2, +4. Okay, then the next group, you tend to have more non-metals than metals in this group, so they are your negative ions, and the trend is -3 for all of these that are non-metals. So that would include nitrogen, phosphorus, arsenic. Arsenic is actually a metalloid, and it can form 3 different ions: -3, +3, or a +5. Okay, antimony, the next one, +3 and +5. And bismuth, same thing, +3 or +5. Okay, the next group is mostly non-metals, so it's negatively charged, -2. So -2 all the way down except for the last one. Okay, and then group 17 or 7A is all, for the non-metals, -1. Okay, which would be all the way down. Okay, and then the last group here are your noble gases, and they are happy the way they are, so they don't form ions at all. Okay, then there was some in the transition metals. Now we'll go back to those. Remember, a characteristic of transition metals is that they can typically form more than one type of ion. So, but there is a trend that helps you remember. Okay, if we start with chromium right here, it can do +2 or +3. And the trend continues like that until we get to copper. So +2, +3, all the way till copper. Okay. And then copper is just a +1 and a +2. Okay, and I remember that because it's in group 11. And this is group 12. And so that 1 helps me to remember that now it's just a +1. And then the other one's a +2. Zinc is only going to form one type of ion, which is a +2. And again, I remember that it's in group 12. There's a 2 right there. Same thing for the one below it. Cadmium, only a +2. Silver, again, I'll look back up at the group. That helps me remember that it's a +1, and that's it. Okay? Gold, also in that 11 group, its charges are a +1 as well, but then +3. Okay, and then mercury, I can't really fit in this little box, so I'm going to write it right up here. And this is our last element that we're going to talk about their charges. Okay, mercury can form an ion that's actually got more than one mercury. So we write Hg2, and each mercury, though, is a +1 charge, so 2 of them together gives me a +2. Okay, this one is called mercury 1. Even though there's 2's in there, it's because the charge of each of them is only a 1, +1. Mercury Roman numeral 1. Okay, and then the other form is just Hg with no subscript, but it still has a charge of +2. And we call this one mercury 2, since its charge is +2. Okay, so these are the charges of all the ions that you'll need to know. You'll need to memorize this if you're in pre-AP. If you're in grade level, we have a chart. Okay. Alright, so back to where we were. Then there's the polyatomic ions. Those are ions that are formed by a group of atoms that overall, when they're joined, have extra electrons, or they're missing some electrons, so that gives them a charge. These, you just have to memorize their names for. There isn't a pattern that you go by, really, that you just memorize the pattern. These, you just memorize their names. So on the back of your periodic tables that I gave you at the beginning of the year, there's a list of all these ions and what their names are. Okay, so this one is called sulfate. You can notice, though, that those that have oxygen in them are usually either end in H or ite. Okay, so this has 4 oxygens. The higher the number of oxygens, usually is the 8 ending. If I took one away and had SO3, then we're talking sulfite. Okay, This one is our positively charged polyatomic ion, which is called ammonium. And this one is called carbonate. Again, it ends in 8, and it also has oxygens in there. Okay, so you just have to memorize those names. And we will be having quizzes to make sure that you do get those memorized. Okay, so once we know a little bit about their charges, that's going to help us write their formulas. Okay, remember when they join together, the positives want to cancel away with the negatives. And a trick that helps you do that without having to count them all up each time is called the crisscross method, which means you bring down and across the charge, and that becomes your subscript. So if I wanted to make a compound out of calcium and chlorine, and I was trying to figure out the formula, it's Ca, I need 1 calcium and 2 chlorines, okay? So we never write once because it's redundant. So we're going to rewrite that then without the 1 as CaCl2, subscript 2. You don't carry over the pluses and the minuses. It's just the number, okay? And so if you look over here, what that does is make those numbers equal 0. Positive 2 for calcium and negative 1 for chloride, but there's 2 of them, so the overall charge equals 0. Okay, so for the next one, magnesium and oxygen. First of all, I would have to figure out or remember or look on my table and get their charges. Magnesium's in group 2, so that reminds me that it's a +2. Oxygen is in the group that are all -2. So when I crisscross, I would get Mg2O2. Okay? But when you deal with ionic compounds, another thing you have to remember is that your subscripts here must always be in the lowest whole number ratio. So 2 and 2 is the same thing as 1 and 1. So we reduce it down to just MgO. Okay, that's what this says right here. Okay, the next one, potassium and chlorine. First, you got to write their charges. Potassium's in group 1, so it's a +1. Chlorine is in group 7 or 7A or group 17, it's a -1. Crisscross, 1 to 1, it's just KCl. Alright, now remember you have to always put the metals first. We would never write this formula as ClK, because metals go first. Okay, the next one has a polyatomic ion in it, okay, but the process is still pretty much the same. You have to know their charges. This is a +1. Cyanide, which you can look on the back of your periodic table, is listed for you with its charge of a -1. Okay, but when you have a polyatomic ion, you have a group, and you can't separate that group. So the way we show that is with parentheses, okay? Only if you need more than 1. But since this is a +1 and that's a -1, I only need 1 of each of those, so we just simply put their symbols together in a 1-to-1 ratio. Okay. Next one, aluminum nitrate. I see this 8 ending right here. So if I was just looking at a name, that would remind me that this is a polyatomic ion. And so I've got a group of atoms, not just a single element. Okay, and the 8 ending also reminds me that it has oxygens at the end. So that will help you find where this ion is so that you know its charge is a -1. Aluminum's charge is a +3. Okay, so I'm going to crisscross my charges. And that means I have Al1, and I'm not going to write the 1. And then I have 3 nitrates. Now this is a group of atoms that cannot be separated. So the NO3 stays just like it is. You would never write that differently, okay? If I need to write a 3 with it, then I have to put it in parentheses so that I keep it as a group, and then I write my 3 after that, okay? If you just brought the 3 down and put it right next to that 3, well then that says you have 33 oxygens and 1 nitrogen. And that's not what we're trying to say. We're trying to say that we need 3 of the whole group. Okay? So we got to use parentheses around the polyatomic ion when you need more than one of them. Okay? Okay, now we have a name that we're going to write the formula from. This name also has a Roman numeral in there. The Roman numeral is what you need when you have an atom that can form more than one kind of ion, like cobalt. Cobalt can be a +2 charge or a +3 charge, and this tells me that it's +2 because that's a Roman numeral 2. So remember, Roman numerals tell you the charge. Charge of the metal. Okay, so if I'm going to write the formula for this compound, I'm going to think about what's the symbol for cobalt, CO, and this tells me that it's a positively 2 charged element, or ion, and then carbonate. Again, it ends in 8, so that's going to tell me it's a polyatomic ion, and I'm going to go look on the back of my periodic table and find that name. And you'll see that carbonate is big C, big O, subscript 3, and its charge is a -2. Okay, so now I would do crisscross, and +2 and a -2 already balances out to equal 0, so it's just a 1-to-1 relationship, and I would just put my symbols together. Those 2's would reduce down to 1's. So that's the formula for cobalt-2 carbonate. Also notice the lowercase o and the uppercase O. Very important, right? Otherwise, you would confuse cobalt with carbonate without those differences. Okay, copper 1 oxide. Remember that the 1 tells me the charge of the copper. So the symbol for copper, Cu +1. Oxide, IDE, is my NV. So that tells me this is a binary compound, which means I'm not dealing with a polyatomic ion. And I'm going to find this on the periodic table as oxygen, because we changed the NV to I. So oxygen is just O, and its charge is a -2. And then I crisscross, and the 2 now is with the copper as a subscript, and oxygen has a subscript of 1, but we leave off the 1's. So there's my formula, Cu2O. Now the next one is copper 2 oxide. Very similar to the one above it. The only difference is your Roman numerals. Right? And remember, that tells me the charge of copper. Now I'm dealing with copper with a +2 charge instead of +1. Oxide is still what it was above, oxygen -2. But now I have a 2-to-2 relationship. It cancels out, equals 0, so I just put them together as CuO. So their formulas are different. That one has a 2 as a subscript. This one does not. Okay? So that's why you need to have those Roman numerals whenever you're dealing with an ion that can form more than one type of charge. Okay, so I'm going to pause the video and let you figure out the formulas for these atoms right here, or ions right here. And then when you've got them all down, push play again and check your answers. Okay, so here are the answers. Here's the formulas for each of these. Notice that the last two here had polyatomic ions. So you start to see those parentheses whenever you need more than one of them. And when you only need one of them, like you only need one of the C2O4, then there are no parentheses. Okay, but I did need more than one ammonium ion, so I used parentheses with the subscript of a 2. Okay. Alright, again, I'm going to push pause and let you answer A through F, and then when you are done with that, press play again and check your answer. Okay, so here are the answers. I've circled them. Make sure you take the time and you check that it looks exactly the way I have it, because anything any different at all would mean you would not get it correct at all. No partial credit. So you can only put parentheses where they're needed. You do not put parentheses around the zinc because it's a single element. It's not a group. So make sure you have written your parentheses in there correctly. Okay? And then down here for pre-AP, there's the old way of naming, where the newer way has you write Roman numerals to indicate which ion you're dealing with. An older version has you actually change the name. So this iron could be called iron Roman numeral 2, or it's also called ferrous. The OUS ending is typically for the lower of the 2 charges. The ic ending would be for the higher of the 2 charges. So since 3 is higher than 2, this one's called ferric. And then if you look at the others that are listed here, you see that same pattern. So for pre-AP students, you have to know this version of naming as well. Okay. Alright, so now we're going to work backwards. We are going to start with the formula and come up with the name. Okay, so your first goal is to identify what type of compound you have. And right now we are only doing ionic compounds. Okay, so that means they all have metals first. And the metals are your cations, and remember, their names don't change at all. It's just the same name that you find off the periodic table. However, the non-metal part does have its name changed. So S is not sulfur, but sulfide. And then you just put those 2 names together. So this one is barium sulfide. Okay, and then the next one, Bi is your positive ion, so you just name it as it is on the table. Bi is bismuth, and then I is iodine, but as an ion is called iodide. So we just put those 2 together, bismuth, iodide. However, if you look on your blank periodic table that you filled in with their charges, bismuth is something that can form more than 1 charge. So when that happens, you have to give it a Roman numeral. Okay, right here. Some names have Roman numerals because there's more than 1 charge of the ion. So we have to figure out what the charge is and then put that in its name. Okay, the easiest way to figure out the charge is to do a backwards crisscross. So that 3 came from here. So plus 3. And there's a 1 here, and if we do backwards crisscross, then that was a -1 was originally here. Okay, so I can tell from that this bismuth is bismuth 3, Roman numeral 3. That's the charge. Backwards crisscross won't work though whenever your subscripts have been reduced, and we'll talk about that in just a minute. Let's first write the name of this compound. Okay, and if we look at C, then Mg stands for magnesium, which doesn't have more than 1 charge. It only can form a +2 ion. So we don't do the Roman numeral here. It's going to look more like number or letter A. And then, so that's magnesium. Its name doesn't change. However, nitrogen becomes nitride. Alright, the next one, letter D. Pb stands for lead. Now lead can form more than one charge. It can be a +2 or a +4. So we have to figure out what charge that is. Now, doing backwards crisscross, let's see if that'll work. So that means this is a +2. And if there's a 1 here, that means this is a -1. And as long as everything equals 0, right, if I have one of these, so I have a total of a +2 charge, I have 2 of these, each is a -1, so a total of a -2 charge, it does equal 0. So we can accurately determine that this was the +2 lead ion. So we must write that into its name. Okay, the next one, letter E, zinc and fluorine. Zinc is an ion that only has one charge, so we don't do Roman numeral. And so all we have to do is remember to change fluorine to fluoride. Okay, then over here to letter F, CO is cobalt. Cobalt is an ion that has more than one charge. So we do backwards crisscross one more time and see that its charge would have to be a +2, okay, which came from here. So we got to remember to write that as a Roman numeral into its name, and also change bromine to bromide. And finally, copper and sulfur. Copper is an ion that forms more than one charge, so we have to figure out what its charge is. Okay, and if we do backwards crisscross, it's not going to work for this one because their subscripts have been reduced. So we need to know what the charge for the sulfur is, which we would know because it's in the group that forms a -2 ion. And that's the only charge it can have, so we know what that one is. And that's what we're going to use to figure out what would go over here. If they're supposed to equal 0, then this has to be a positively 2 charge, so that they come out to equal 0. So now I've figured out what copper it is. It's copper 2. Okay. Next, we're going to name compounds that are ternary, which means they have 3 or more different elements in them, which really means you're dealing with a polyatomic ion, okay, which they have special names for those, all right, which you have to memorize. So to name them, you just name the first element or first metal according to its name on the periodic table, and then you put that with the name you have memorized for what that polyatomic ion is called. You still have to remember to put in Roman numerals whenever you're dealing with a metal that can form more than one ion. However, lithium is not one of those kinds. Lithium is always just a +1. So I'm just going to put its name, lithium, with the name of CO3, which is called carbonate. So lithium carbonate. Okay, the next one. Again, you're looking at your metal, and then you know everything that comes after the metal must be with your polyatomic ion. So if I know Cu is copper, then I find SO4 on the back of my periodic table, and I see that it's called sulfate. So I've got to put those two names together, and then I also have to include a Roman numeral because copper has more than one type of ion. So let's figure out what Roman numeral I'm going to need. Remember, it's based off what it's joined with. Sulfate is a -2 charge, and I have a total of just one sulfate ion. And so the negative is a -2, the negative side. And this is the positive side, that must mean it's +2, so that when they add, they equal 0. So now I know what Roman numeral to use. Copper 2 sulfate. Okay, the next one. I see my metal is zinc. That means everything else after it is the polyatomic ion. And I also see parentheses, so I know I'm looking for what's in that parentheses, NO3. NO3 is called nitrate. And so I'm just putting that name with the name of Zn, which is zinc. Zinc is not one that can form more than one type of ion, so we do not need a Roman numeral. So I'm just putting zinc together with nitrate. Okay, the next one. My metal is barium. So I know it's going to start with barium. Then I look in the parentheses, OH. I'm looking up what the name of OH is. Or if you're in pre-AP, you of course would have to have that memorized. Grade level, you would look at the back of your periodic table and see that it's called hydroxide. So I'm just putting those two names together because barium does not need a Roman numeral. Barium hydroxide. The next one actually has the polyatomic ion written first. The ammonium ion is the one exception to the rule where you're not going to have a metal written first. This is our only polyatomic ion that we deal with on a regular basis that is made up of only non-metals, and it's actually positively charged, so it would have to be written first. And so you should just recognize and remember that that one is ammonium, and now we're looking for what chlorine is, and we call chlorine, Cl, as an ion, chloride. So we're just putting those two names together, ammonium chloride. And one more to go. Fe is our metal, and it is a metal that can form more than one charge as an ion, so we have to figure out which one it is. Let's see if backwards crisscross will work. So if I see that there's a 3 there, I'm thinking this is a +3, and then the charge for hydroxide is a -1, and if I have 3 of them, then I have a total of -3, and so yes, backwards crisscross has worked because we did not reduce any of our subscripts. So now I know that the charge of this iron is +3, so it's called iron, Roman numeral 3, hydroxide. Okay, so that is where we're going to stop today. I hope you have filled in your note packet that I gave you and that you bring it with you to class, because we're going to be working on this some more in class.